Hello, today we're going to talk about exponential functions graphing. Alright, the first thing I'm going to show you is basically the transformations you can do with it, or the different parts of it. So I wrote out a whole long exponential function. Each part means something when you're graphing it. I'll start from the back here. This right here is what is called the horizontal asymptote. So what the horizontal asymptote is, so when you're graphing an exponential function, it looks something like that. That's an exponential growth. So there's this imaginary line that you can't see on the graph of a point to where it'll never ever reach. So let's say this right here is at 2. We'll say the horizontal asymptote is at 2. And this it's at -5. That graph, or that exponential function, will never reach 2. It'll get to 2.00000000000 100 times 1. But it'll never, ever, ever get to 2. And that's what the horizontal asymptote. It's an invisible line showing where the exponential function will never get to. Right? This is your base here. If you ever see a negative up here, that means you have a reflection across the x-axis, or the y-axis. Because when you have a negative exponent, what does that do here? So if I have 2 to the negative x, when I simplify that down, that gives me 1/2 x. 1/2, so 2x is this when I graph it, which is a growth. All right? When I graph 1/2 x, what that does is it makes it a decay. So all I did was take my growth and reflect it across the x, or the y-axis. And that's the difference between a growth and a decay. So whenever you see that negative is actually saying this is 1/2, and it reflects it across the y-axis. This number right here, this represents two different things. If this number is somewhere between 0 and 1, it's called a shrink. It's a vertical shrink. Right? What it means is, or I can show you that where I'm going. And if this number is greater than 1, it's a vertical stretch. What that means is, if I have a graph here, let's say this graph goes through right there. All right, if I put, let's say, a 1/2 as this number right here, that takes this shrink and puts it lower. If I have a number like 3, that stretches it up. Right? So a fraction makes it go lower, or go through the y-axis lower. The bigger number makes it go through higher. It stretches it. Right? And the negative up front, go to green. My negative up front, this means a reflection across x-axis. Now, all of this is just to help you understand how to graph. It's not very necessary for you to do, but it makes it easier to graph and understand it. You can just graph without actually having to put the numbers in. It's just another way to graph if they give you something, or to transform an equation and figure it out. So this helps you write an equation. So if I gave you this, knowing all these transformations will help you write an equation from it. Or if I give you this, this will help you graph it, either way. But this is the basics of it, and I'm going to show you 4 different examples of how to graph it using this. This is our first one. So I told you there's no back number here, or this back number is what? It's your horizontal asymptote. So your actual equation here is a times bx plus or minus c. Right? Now, because there's no number back here, I know my horizontal asymptote. So there's nothing back here, and I'm going to write out all the stuff I know. So my horizontal asymptote, I know it's going to be y is everything greater than 0. All right, that might make sense, it might not. So what that means is everything greater than y here is going to be a part of it. My domain, my y-intercept. So my y-intercept is found by simply just putting 0 in for there. So if I do 2 raised to 0, and this is what you should have learned from graphing just regular stuff. Whenever the x is 0, you get your y-intercept. So 2 to 0 is 1. So my y-intercept is 0, 1. And I can place that right there. And I know my horizontal asymptote is going to be at 0. So without even plugging in anything, I already know 2 things about it. And there you go. Domain is always going to be all real numbers here. I'm just going to write it as that. Domain means it's going both ways all the time. Range. All right? The range, and if you haven't watched interval notation, go ahead and watch it now. So my range here, without even having to graph it yet, I know my range is never going to be at 0, so it's going to be everything y is greater than 0. Sorry, I did this wrong. It should be y equals 0 is our horizontal asymptote. Sorry about that. So y is everything greater than 0. Because our range is on our y-axis, so we know our line's going to be up there because that's where our vertical, or that's where our y-intercept is. So it'll be everything greater than it. So let's graph it. We'll do it the written out way. So we'll do just -1, 0, and 1. So -1, plug it in. It gives me 1/2. 0 plugged in gives me 1. 1 plugged in gives me 2. So if I graph those points, -1, 1/2, 0, 1, which we already knew, and 1, 2, we can graph our line. And there you go. And that shows you that your horizontal asymptote is y equals 0. This line will never actually touch y equals 0. The y-intercept is where it went through. You can plug 0 in if you want to get to 1. Domain is going to be all numbers for infinity to infinity. The other way you can write the domain is -infinity to infinity. Range is y is greater than 0, or you can write it as 0 to infinity. Now I show you both with these ways because this is interval notation right here, because I don't know how they're going to show it to you. There's multiple ways to do it. So that's how you show the range, that's how you show the domain. And there's your graph. All of this out of a simple graph is all stuff you can tell. We're going to do. All right, now for our second example, 2x minus 5. The minus 5 now is our horizontal asymptote. So 1, 2, 3, 4, 5. This is going to be my horizontal asymptote. My horizontal asymptote is a visible line to where my exponential function will never ever touch. All right, so I can say y is going to be everything greater than, or is equal to -5. Because if I graph y is equal to -5, it'll be that line right there. That's my horizontal asymptote. It's just a line there. I think that's how you write it. Yeah, it's just going to be right there. So my y-intercept, I can find out in a second. What's my domain going to be? It's going to be everything from -infinity to infinity, or you can write as all real numbers. All right, now let's graph this. We're going to do it the old school way where we write stuff in, just because that's a little bit easier. I'm going to use -1, 0, and 1 just for speed's sake. So f of -1 equals 2 to the -1 minus 5, which gives us 1/2 minus 5, which is -4.5. We plug in 0, gives us 1 minus 4, and we get 1. So f of 1 equals 2 raised to the 1 minus 5, which is -3. So we graph these. So at -1, we get -4.5. At 0, we get -4. At 1, we get -3. All right, as you can see from the first one to the second one, all I added was the -5. All right, so that's what we're going to do this whole time. So 2x, then I switched my horizontal asymptote, so that shifted down 5. If I had said +5, it would have shifted it up 5. Horizontal asymptote just shows the very, very bottom of the exponential function. All right, my y-intercept I know now is 0, -4. My range now is everything from my horizontal asymptote, which is -5, to infinity in this case. I put the parentheses, and if you don't know interval notation, just go look at my thing. There you go. And there you go. All right, now for our third one. So now I started with the 2 to the x, then I put in the -5, which switched the horizontal asymptote, or the invisible line that you'll never get to. And then I put a vertical stretch up front. So what that's going to do is take this point and move it up. So my horizontal asymptote is still at -5. All right, my y-intercept we'll find out in a second. My domain is always going to be this, or all real numbers. All right, so x and y do -1, 0, and 1. Plug that in. So 3 raised to the 2 to the -1 minus 5 gives me 3 times 1/2 minus 5, which is 3/2 minus 5, which gives me 3.5 negative. Yep, 3.5 negative. Plug in 0 for it. It gives me 1. Gives me 3, -2. Yep. Then 1 I plug in, and that gives me 6, 1. All right, so now let's graph these. So -3, 5. 1, 2, 3, 5. 0, -2. And then 1, 1. Then I connect my dots. All right, so what you see there is all that did is it stretched my function. That's why it's a vertical stretch, because it took it from there, which is what I had here, and it moved the point up, all the points up. So there you go. My y-intercept now that I just got is 0, -2. And my range will be everything from my horizontal asymptote, which is -5, to infinity. That did not change whatsoever. All right, now the change I made was put the negative up front. What the negative up front will do is it'll reflect it across the x-axis. So it'll go from here to over here now. Still be growth, but we'll just change sides. So my horizontal asymptote is still the same at -5. Hasn't changed at all. But now, let's find our new point so we can graph it. Plug in -1 here, plug in -3, 2 raised to the -1, -5, that gives me -3, times 1/2, -5, gives me -3 over 2 minus 5, which gives me -6.5. Notice how now that point right there, which last time was right there, just flips over. So right here from 5, it's 1.5 up. Now it's 1.5 below it. All you're doing is just taking it and flipping it upside down. Plug in 0 and we get -8. And then we plug in 1 and we get -11. If you go back and look at the last one, it was it was 1.5 from this one to this one, and then it's 3 from that one to that one. All right, so you can see it here. 1, 2, 3, 1.5. So even without even looking at the numbers that I have over here, I can look at this and I can graph the entire thing without even looking at my numbers that I did over there. All right. And now, since I haven't looked at my numbers, let me check it. So my first answer should be at -1, 6.5. My second number should be at 0, 8, -8. And it is. And my last one, 111. And that's where it is. All right. So all I did was take the green one and flip it by giving it a negative up front. My y-intercept is 0, -8. My domain is all real numbers. And my range is now different. My range now, since it's flipped, is my y going to positive infinity? No, my y is now going to negative infinity. You always put the smaller number first. And there you go. There's your new range. I'm going to do one more. All right, now here's my last one. Now I put a negative up with my x. I'm going to rewrite that because I know that negative by my exponent law is actually going to give me the equation like that. All right? So now I have -3, 1/2. These are the same exact thing. If I have a negative exponent, I can get rid of the negative and just flip whatever's inside. So now what this is going to do, it's going to take it, and if you remember what I wrote at the beginning, it's going to flip it across the y-axis. So now we flipped across the x, and now we're going to flip across the y. So this point will move there, this point will stay the same, and this one will move over here. I don't really even have to do this out to figure out where I'm going to put it, but I'm going to do it just for show. All right, my horizontal asymptote is still the same thing. Y equals -5. And let's do out our three numbers. -1, 0, and 1. So -3 to the 1/2 times -1 minus 5 That flips that, so I get negative 3, 2 minus 5. Negative 6 minus 5 is negative 11. And that's exactly what I said was going to happen. So we were at 1, 11, negative 11. Now we're at negative 1, negative 11. I guarantee the next thing we do is going to be negative 8. And I have not done these out yet. So I plug in 0 for that. That makes that 1. Negative 3 minus 5 is negative 8. So now I have the point right there and right there. How much you want to bet? My next answer is going to be 1, 6, negative 6.5. This is going to be negative 6.5. And I have not done this yet. So let's see. Negative 3, 1/2 raised to the 1 minus 5. So that's negative 3/2 minus 5. So that's 1.5, so that gives me negative 6.5. Look at that. I didn't have to do this at all. It's exactly like I told you it was going to be. And there you go. Angel Wayne, the vein is all the same thing. Alright, I just showed you a bunch of different ways to graph stuff. This has been a long video, but it showed you how to use the transformations along with graphing. I can predict what my graph is going to look like just by knowing my transformations. I do not need to actually do all the points out and graph it if I understand my transformations. But this is also just showing you how to graph it and understand what everything means in an exponential. It is a greater amount of information than you get from a just a linear function. There's also end behavior, but I'm going to do end behavior. It's its own video, not to drive people crazy. All right, I hope this helps and good.